What's here? Good boy. Very good. All right, you can
When
have a
parrots
regular
speak
nut.
English and gorillas use sign language, we're naturally moved to reply, engage in a conversation. But do animals really have language?
How many green blocks?
Most wild animals communicate amongst themselves. Breaking their code is not easy. Even with the right dictionary, would we still know what they really mean? Perhaps theirs is nothing more than a language of the senses, simple but effective means of expressing fear, excitement, anger, and of course, danger. Early warning systems are vital tools of survival in the wild, and there are many ways of communicating danger, not all of them audible. In the rainforests of Australia, web spinners live in labyrinths of silk spun from their feet. They work endlessly to repair and extend their fortress and rarely venture out. Predators scratch around for a way in. Green ants, expert at trench warfare, are particularly unwelcome. A web spinner detects a breach of security and trips the alarm by beating a retreat. In the panic to escape, it sends vibrations throughout the network of silk. As the shockwaves travel along this primitive information highway, the others evacuate the main nest. Communication is a lifeline, whatever form it takes. But here, the messenger was not consciously warning the others, merely trying to get out of a tight spot. The bearer of bad news must pay the ultimate price.
Like pulling like perfectly. That's great.
Dr. Mark Hauser, professor of psychology at Harvard University, is an expert in animal communication.
I would define communication as the exchange of information between two individuals or more, where the communicator is in some sense trying to manipulate the behavior of the receiver.
Few places on Earth resonate with the diverse communication skills of animals more than Africa. In the arid scrub of northern Kenya, one animal is a master of the art of manipulation. Meet the indicator bird, aptly nicknamed the honeyguide. It feeds mostly off insects and is especially partial to bees' eggs and larvae, but it needs a helping hand to get at them. The bird looks out for members of the Baran tribe and chatters to attract their attention. The tribesmen know the honeyguide will lead them to the pot. The bird stops from time to time to let the men catch up. In turn, they must let the bird know they're still on its tail.
Here. Ja. Ja. Hör det. Hör det. Hallå där. Hallå där.
Once the hive is located, the bird waits patiently at a safe distance while the men get on with the job of confronting a colony of angry bees. True to their side of the bargain, the men leave their guide a generous tip. If the indicator bird has learned to sing for its supper, conscious communication between humans and animals can get far more sophisticated. A language of sorts turns man's best friend into man's best worker. Johnny Wilson is a shepherd on the Scottish borders, responsible for the care and protection of 700 sheep. He couldn't do this without the help of his working dogs. Johnny has 8 border collies. Intelligent, obedient, and tireless, the dogs make ideal drill sergeants to marshal flocks of unruly sheep scattered about the Scottish hills. One good dog is worth a dozen men, as long as Johnny can make himself understood. He uses 6 basic voice commands.
Come by, Rob. Look back.
Look back tells the collie to round up stray sheep.
That'll do, Rob.
That'll do, and the collie must return to his master.
Away to me, Rob.
Come away to me, move from right to left.
Bye, Rob.
Come by, from left to right.
There. Steady on.
Steady on, move more slowly,
Lie down.
and lie down. When the dogs are almost out of earshot, Johnny whistles his commands. The crafty collies seem to be bilingual.
I start with voice commands. Once I have the dog on the commands and they know "Kaway to me" and come by, all I do is I'll say "Kaway to me, Rob," and then I'll go just as he's going. And I can guarantee you with a border collie, it'll just maybe take 2 days at the most to put them onto that whistle. For some unknown reason, they go into whistles easier as they go into voice commands.
The shepherd keeps in constant touch with his dogs one way or the other. It's a working partnership between man and dog, born out of sound communication.
Lie down. Lie down there.
What about actual language? We all talk to our pets and we often think they understand. Johnny Wilson can tell his dogs where to go and what to do, but he can't tell them what he had for dinner or whether it was tasty. Dr. Hauser says language transcends simple communication.
Language comes in that, in some sense, it's a form of communication, but it also refers to the kinds of internal computations that the mind has available to it to both refer to things in the world and to take discrete elements like words and combine them into larger, meaningful chunks.
Language has the power to reach far back into the past. It uses words and symbols to evoke the present and points to the future. It describes thoughts and emotions, as well as more basic things. The word snake refers to a legless reptile, and fig, a specific fruit. Baboon defines a species of monkey. Simple names, combined into phrases and sentences through grammar and syntax, evoke the wonders of life itself. The baboon shakes the tree to dislodge the snake and eat the figs. So is a baboon capable of this kind of language? Or are the sounds animals make little more than instinctive reactions to fear and pleasure? Language takes on many guises, not just noise or spoken words, but abstract and symbolic forms too, like music, mime, and of course, dance. For centuries, beekeepers have marveled at worker bees dancing on their honeycombs. Scientists believe they were using a symbolic language to tell their co-workers where to find food. If a bee finds food close by, it returns to the hive and performs a pirouette. If the food is further off, the waggle dance is called for, a slow figure of 8 with a bit of a shimmy in the middle. According to popular theory, the angle of the waggle to the sun indicates the direction of the food. The bees leave the hive and follow their compass bearing until they find what they're looking for. Instead of words, this sun dance conveys both distance and direction. But could this really be true? Modern textbooks still support the theory, though scientists now interpret the choreography in a dramatic new light. Dr. Adrian Wenner of the University of California, Santa Barbara, comes from a family of beekeepers. He started out believing in the symbolic language of bees.
My whole doctoral dissertation was based on the fact of bee language, because no one had any reason to question it. I didn't realize that this was a hypothesis generated and that had never really been tested properly.
Dr. Wenner does not deny that bees dance, but his experiments put an entirely new spin on their performance. He believes that the dance has more to do with transferring odor than communicating through any kind of abstract language. Place an odorless but sweet solution near the hives, and few bees take to it. Use the same solution, this time with a cotton bud dipped in clove oil, and the bees pick up the scent. The first bees return to the hive carrying minute traces of clove. Within minutes, others hone in on the dish. Half an hour later, and the bees swarm.
Now, if you watch the bees that are paying attention to a dancing bee, they're sideways to it. And this, of course, means that as the bee waggles along, it can be knocking odor molecules onto the antennae of the receiving bee.
The scientific world is now coming round to Dr. Wenner's view that the bees' dance may not be any kind of language at all.
There's something called Occam's razor, or oftentimes known as Morgan's canon, where when you have two possible explanations for behavior, that you should take the simplest one. Bees have brains the size of a grass seed. It was not meant for thinking.
You wouldn't tar a monkey with the same brush. Vervet monkeys are social animals, and with their bigger brains, it would seem natural for them to develop linguistic skills, at least to protect each other. Vervets live in tight family units. About the size of a small dog, they're coveted by any number of predators. Most animals use an all-purpose danger call to warn against immediate threats. But anything as vague as help or run would be disastrous for the vervets. Because they are attacked by different predators, they need to know what the threat is in order to escape it. When they see a snake, the vervets sound the alarm and keep a watchful eye out for the intruder. Now listen to this. The leopard signal triggers a frantic dash for the thinnest branches in the canopy, where the leopard has no chance. That's the vervet alarm call for eagle. This time, the monkeys seek thick protective vegetation to stay hidden until the coast is clear once again. By having 3 different alarm calls, the vervet's self-preservation system is much more efficient. So are these monkey words for snake, leopard, and eagle? In the late 1970s, a group of scientists decided they were. It was a bombshell that changed the way we think about animals, though some scientists, like Dr. Hauser, took it all with a pinch of salt.
That was the first indication that animals may have something that's kind of like a word. But if you really look in detail at the system, it looks to be very, very different from the human system of words. If the animal system were truly like the human system, there's no reason why they would stop at describing a small number of things in their environment. It should be explosive. Once you have the notion of reference, you can refer to things with an arbitrary relationship between sound and meaning. You're done.
Vervet monkeys remain largely tongue-tied compared to humans, though their voices are vital for survival.
The second and fundamental difference is that when animals communicate, they seem to be communicating about the here and now. I see a leopard, I give a leopard alarm call.
The next step to develop real speech would be a giant leap for the animal kingdom, and a giant leap of faith for scientists. In the 1950s, Keith and Catherine Hayes started a language experiment with a chimpanzee called Vicky. Vicky grew up with the Hayes' own children, and the speaking program began. Progress was slow. After 4 years, all Vicky could manage was mama, papa, cup, and up. The experiment disappointed those who had hoped for a breakthrough, and it coincided with another major discovery. Apes may look and act like us, but because of the position of their larynx, they're physically incapable of real speech.
Now, who am I? Papa? Papa? Can you say what this is?
Apes and humans are poles apart. Dr. Hauser is fascinated by the different evolutionary paths animals and humans have taken.
The, to me, extraordinary thing about thinking about the evolution of the mind is that animals were kind of humming along, thinking rich thoughts, but couldn't talk about them.
The evolutionary fault line between man and ape is speech.
I can have a relationship with somebody and go to somebody who's never seen or heard anything about it and tell them absolutely in detail what I've just done. That is an incredible capacity. Now, it doesn't mean that other animals are not interesting. It just means that that's something that we do and other animals don't seem to be able to do.
If speech is unique to humans, does that mean we also have a monopoly on language? Dr. Penny Patterson has spent years trying to prove animals do have linguistic skills, even though they don't have the vocal apparatus to speak. Her experiment with Koko began in 1972. She knew Koko would never talk, so she used American Sign Language. Over the years, Koko grew, and so did her vocabulary. She now knows 1,000 signs and understands 2,000 spoken words. Koko became a star. Penny's relationship with Koko grew so close that she dropped any pretense at scientific objectivity. Her work is controversial, and many scientists and linguists believe she gives Koko far too much credit. Who wouldn't? Koko takes her education very seriously. Problem is, because primates look like us, can we really expect them to be like us?
A nice move I like to make is to say, take any given behavior you see in an animal that looks like us and just substitute something that doesn't look like us, like a slug or a chicken or a bat, and now imagine running the same kind of explanation on that particular species. If you find you can do it as readily, fine. But I think the cautionary note is that it's too easy to fall into an interpretation of an animal's behavior just because it looks like us.
So is the ape language camp deluding itself?
You were brave, and you were really brave.
Dr. Sally Boysen runs a kind of school for primates at the Ohio State University Chimpanzee Center. She's taken chimps a step further and teaches them a wide range of cognitive skills. Her team talks to the chimps in English, and they understand a lot more than Scottish Border Collies. The latest exercise is word recognition.
You looking? Find orange. Orange. Good boy. Good job.
Bobby is tested on 9 different foods. The researcher, Stephanie, asks him to match an item with a word on screen. The words appear randomly, so Bobby must make the correct choice.
All right.
Bobby deserves more than congratulations.
Good job. Pop.
Great.
Bob, where's Pop?
Great.
Uh-oh. Bobby, where's Pop?
We're still in the early stages of looking at the chimp's ability to associate English words with foods and the names of other chimpanzees, etc. We're working with whole word recognition right now, but we will return to the individual alphabetic characters so the animals construct the word also.
Banana. Where's banana? Banana.
Bobby scores consistently high marks, which is just as well, since his appetite for M&Ms is insatiable. He really seems to be thinking about a problem, not just guessing.
Good job, Bobby. Good boy. Come on, peekaboo.
The Chimpanzee Center teaches more than just reading, writing, and arithmetic.
Emma, look.
Dr. Boysen's team wants to find out how well chimpanzees communicate vocally with each other. How much information do they really exchange?
We are currently interested in natural chimpanzee vocalizations as well. So we've been exploring just one category of vocalizations, and those are food barks.
In the wild, as well as in captivity, chimps produce sounds when they see food. Are these food barks real words, or just emotional responses? At the Chimpanzee Center, the chimps react to their likes and dislikes. Their food barks are recorded.
Good girl. Good girl. Sheba, can you sit down, not on your chair? Stay right there. Good girl.
Back in the classroom, another chimp listens to the recordings before identifying the barks.
Good, Sheba. Peanuts. Good job, Sheba.
We played a very simple game with the chimps. We played the recorded vocalization, say a vocalization that was collected when they saw lettuce, not a big favorite. And then 4 pictures appeared, and they were to pick the picture that was possibly being referred to by the vocalization. And we were quite surprised when they actually were able to specify. That is, not only could they pick good foods, they could pick the specific good food.
To the human ear, food barks sound pretty much the same.
Okay.
Dr. Boysen's next challenge is to crack the chimp's code.
So now what we're going to try to do over the next several years is try to tease apart what part of that call really contributed to the decision making. That is, how did they make a decision between M&Ms and grapes when many of the acoustic features were very similar? High frequency, rapid periodicity, rapid temporal features, and very different from not so good foods where the frequencies are lower and the time course is very different, as opposed to which are very different.
This is exciting new scientific territory.
Sorry. You ready to pay attention?
It could lead to understanding far more about the evolutionary divide between apes and humans.
Good, Sheba. Good girl.
So we think it's a really interesting new direction to explore to see what kinds of possible vocal behaviors might exist in the chimpanzee that could have been shared by a common ancestor. And when the two species diverged, the chimpanzee line and the human line, from this common ancestor, what parts of that neurological organization did they maintain, but the outcome was very different? That is, we went on to speech, they went on to their more finite call structure.
It helps that chimps are noisy, talkative creatures with at least a semblance of speech. Other highly social animals seem to communicate in absolute silence. Elephants wander all day in search of food and water. They can consume 250 kilos of food and 160 liters of water every day. Herds need to keep a distance from one another, so there's enough to go around. So how do they coordinate their movements over such vast areas, especially when resources are scarce at the end of the dry season? Dr. Caitlin O'Connell-Rodwell, a biologist from Stanford University, has found a way into the mysterious sensory world of elephants.
Welcome to Zoo Lights, the new high voltage...
Elephants inhabit an acoustic environment of their own. Where dogs and whales are attuned to high frequencies, elephants find themselves at the bottom of the scale. They pick up low frequency or infrasonic sounds well beyond human range.
Infrasound in elephants was really discovered in the mid-'80s by Katie Payne. She was in a zoo and there were some Asian elephants and she kind of felt this fluttering and realized that they were actually vocalizing, and they got some low-frequency equipment and recorded these infrasonic calls.
Elephants may rely on more than their trademark ears for information around them, especially over long distances. Low-frequency sounds travel, at best, 10 kilometers through the air. The same sounds or vibrations travel much further through the surface layer of the ground. So are these elephant boots made for talking as well as walking? Elephant feet take quite a pounding and are extremely sensitive. These are more like deep ruts than scars. It takes zookeepers more than just a bit of spit and polish to keep elephant feet healthy. A shoeshine boy's nightmare. At the Oakland Zoo near San Francisco, Dr. O'Connell-Rodwell and her team prepare to test an elephant called Donna to see how receptive her feet are to sound. They're going to simulate seismic activity through the ground.
It's pretty good.
That's 10.
So the idea here with Donna is to, she's going to be standing on a force platform we're delivering vibrations of 5 hertz, 5 hertz, 10, 15, 20 hertz, and then lowering the amplitude of that signal every time to try and understand what is the minimum amount of vibration she can detect.
Donna is a female African elephant. At first, she's a bit over-enthusiastic, but she soon settles in. Every time she feels a vibration through her feet, she must touch the red disc.
The reason we're doing these studies in the Oakland Zoo is to understand exactly how sensitive the elephants are to vibrations of any kind. And we're also planning, once we get this down in this captive environment, to do it in a somewhat semi-captive environment in either Africa or Asia, where the elephants are more accustomed to paying attention to the environment with not so much noise. She just did that on her own, didn't she?
She's done several on her own.
That's great. After rewatching all those...
If elephants sense vibrations through the ground, especially those of faraway herds, what chance is there that they have their very own language?
In thinking of animal language and elephant communication, it's a very beautiful thing to see elephants up close communicating. They're very tactile animals and very visual animals. They're very aware, their eyes light up and they shake their head at each other. So there's a lot going on in close quarters that is most certainly a language for them.
If only animals could speak our own language. Parrots do, often with amusing results.
Go up here, I'll give you some real treats. Good boy.
But parroting is the dubious art of imitation without understanding what's being said. Empty words.
You're right.
Well, I know I'm right.
Dr. Irene Pepperberg, a professor of psychology at Brandeis University outside Boston, has spent much of her career teaching an African grey parrot called Alex to really understand what he says.
Alex was a bird I bought at a pet store. I tell people not to do that, but I needed a bird who was not special in any way. I had to show that I could take a so-called off-the-shelf bird and do all these experiments and show what they could do. Come on, what's different? What's different?
Color.
Good birdie.
Good birdie.
That's right. You want to know?
Good birdie indeed.
Good boy.
But is Alex, the pet store parrot, just paying,
get a much
well,
better nut
beak service to intelligence?
You're
Or does his
very
bird
good.
brain
You're
do
waking
more
up a
than
little.
just repeat exercises?
Change shapes. We'll change shapes. Okay. All right, what shape? What
Here,
shape?
a new recruit called Griffin learns the relationship between sound and meaning by observing another human student.
What shape?
You're so close. You're so close. What shape?
6 corner.
6 corner, you're right.
I got 6 corner wood. I want a nut.
There you go. Here's
I got
nut.
a nut.
Mm.
Oh, good.
Yummy nuts.
6 corner wood.
Yeah, come on,
Okay,
Griffin.
Griffin. Look.
Now it's Griffin's turn.
What shape, sweetie? What shape? What shape?
Corner. That's
Yes.
right.
How many corners? You're right. Say the whole thing. How many corners?
That's right.
6.
Corner.
Good boy. Yo, you're so good.
Griffin
I'll give you
is
a
still
little
a
nut.
beginner.
But I want you to say the whole thing.
But smart Alex is an old
It's
hand.
6 corners.
He's been
Can we
doing
say it
this
all
for
together?
26
What
years.
shape?
Corner.
Yeah. How many corners? Say the whole thing. What shape?
Corner.
Yes, Alex,
right,
you're
Alex.
right. Alex, you're a good birdie. Yes.
Alex can name about 100 objects and answer questions on size,
How many orange
shape,
blocks?
colour and matter.
How many
But
green
that's
block?
kids' play.
How many green block? How many green block? Come on, how many green block? No green block. How many green block? Come on, how many green block?
4.
That's
Good
right.
boy.
There's 4 green blocks. Very good.
It's a struggle, but
Yeah,
Alex
that's right.
gets
Good
there in
green
the
block.
end,
How many?
processing a pretty large bite
How
of
many green
information.
block, and we can finish this task, okay? How many green block? What warbirds do is not pure counting. I call it recognition of numbers. What he does is not a simple, what's called subitizing, a perceptual recognition. That's like when you see dice or dominoes and you know there's 12 things, but you don't count them. We give him complicated tasks where we throw colors, red and blue balls and blocks on a tray, and we ask him how many blue block. And he couldn't do that by a perceptual mechanism because there's a big melange of stuff. And we gave this task to a 4-year-old child. The 4-year-old child had trouble with it. So he's got some sense of number. And we have to work at it to see if it's true counting.
He's just trying to sabotage you.
Okay, let's do one more.
Alex is not just a pretty boy.
Can you tell me how many orange wool we have? How many orange wool? How many orange wool?
Good boy.
Right. Good bird. Want to know?
Okay, here you go.
What color bigger? Orange. That's right.
Good
Orange
birdie.
is bigger. Orange is bigger.
Good boy.
That's right.
Alex's flair with words and numbers is impressive, and yet something tells Dr. Hauser that he might just be pulling the wool over our eyes.
Corner.
The work that Irene Pepperberg has done with Alex shows that Alex can learn symbols for numbers. In Alex's case, and unlike the chimpanzees, actually words. So Alex knows the words for 1, 2, 3, 4, 5, and 6. Just like the work on the chimpanzees, however, Alex goes no further than that, never understands this is a list, that the list can be built by a successor function, that you just keep adding 1. For each step, it took Alex as long to learn what 1 means as 2 and so forth. So Alex's capacities are very much like the chimpanzees.
Yeah, you're starting.
The homework now covers the basic phonetic units of words like R,
That's
E,
right,
and Ch.
birdie.
What sound gray?
That's
right.
Alex left the
Good
pet shop to
birdie.
embark on a long, fascinating journey. But is he any closer to the holy grail of real language?
What Alex has and the other birds have is a complex form of communication. We've trained them to use certain sounds of English speech. It's not language the way you and I would speak language.
What shape? That's right. How many?
As we train them, we learn that it's more and more complicated. Now, no matter how far we go, still, Alex will not be able to give a lecture for me. So there's going to be elements of human language that they can master. At some point, you can come into the lab and you have a conversation with Alex, but it's not the same conversation you have with me. It's a conversation you may have with a 3-year-old child. So it's all a matter of degree.
At Marineland in the south of France, killer whales must learn the ground rules of grammar before they can perform. 7 meters long and weighing about 5 tons, training them requires gentle persuasion. They're rewarded for their achievements with food and affection. Trainers use a complex system of sign language to communicate with the whales. They understand dozens of signs. Killer whales have exceptional vision and are highly intelligent. They respond to the subtlest command. John Kershaw, General Curator at Marineland, knows these whales intimately.
There are as many signs possible as a trainer has imagination. Really, these guys can take on board everything we can throw at them, and they take it all in. And there seems to be no end to their memory. We teach a language to these animals. We teach them signs. These signs correspond with different behaviors that we require, and we can even push things a little bit further in putting together these different signs to form what you could call a phrase, I suppose, if you wanted to, but in actual fact for the animal is just a list of requests which he can understand as one behavior, and he can perform all these things at once, bringing out all the different things that we've asked for, which is pretty difficult to understand.
Their ability to understand multiple commands like swim over there on your back spitting puts killer whales at the top of the animal language class. Most animals, including chimpanzees, have difficulty executing more than one command at a time. Whales respond to a basic sign language of complex phrases. What about syntax? Is this too much of a leap for the killer whale? In English, David loves Jane does not always mean Jane loves David. The words are the same, but not the order. Woe betide the suitor who conveys the wrong meaning. To test virtual syntax on a killer whale, the trainers first use two familiar commands, go and spit. The commands are unexpectedly reversed, spit and go. It's a hesitant performance, but the penny seems to have dropped. The novelty of syntax, meaning through word order, enters the whale's mighty faculties for the very first time.
We tried here to change the word order in one of the phrases we use very regularly and see if it influenced the animal's behavior. And simply by not reinforcing what he was doing, we were able to push him to guess his way into what we wanted. It took about an hour for us to teach the animal that there was a difference between go over there and spit and go over there. And the animal finished tentatively by understanding what we meant. It was sort of a little spit and then a go over there with a sort of a look towards us going, is that really what you wanted? It's not what I normally do. But it can be done very easily. We can change word order and it can have an effect on the animals.
So phrases and word order, which are so important to human language, are easily taken on board by killer whales. Surprisingly difficult too for animals is pointing. Even young children struggle with this.
Most animals, if you put your arm out like that with your finger extended, they'll look at the end of your finger and wonder what they're supposed to do with it. Whereas a killer whale will understand that that movement means over there. So over there exists in killer whale language. We have to teach it. But it's not that difficult to teach. We can teach them by the use of a target and by the use of a second person who intervenes at that moment, that it is interesting at the moment that I do that to go over and see what's going on over there.
Killer whales seem to take everything in their stride. But even these megastars at times forget their lines. And when that happens, they all lose the plot. Is one whale deliberately confusing the others?
We're working with two animals at the same time, and both animals in front of one trainer. One trainer will ask the animals to do something, and they'll both go off and do it wrong, or they'll both go off and do it right. What happens is a little bit like walking down the street. Two people walk down the street and you come to a fork in the street like that, and one person will go, come on, down here. And they'll go down one side or the other, and the other person will very happily follow. Be it right or be it wrong, he will happily follow. And it's no more complicated than that, really.
The killer whales of marine land seem ready to follow their trainers to ever greater heights. If they ultimately fall short of learning a full language, it may not be for lack of ability.
I'm sure they're totally capable of understanding a language. They are capable of taking on board the information necessary to be able to use a language, probably, but we would have to teach them. Because for them to have a very complex language, they would have to have a need for a complex language. And in fact, their sense of observation is sufficient. They don't need a language. So if you ask me, does a killer whale in the wild have a language, I would say not particularly a developed language, no.
Mastering complex sign language in captivity is a far cry from the whale's natural vocalizations in the wild. So how well do they communicate with man in their own environment? Jim Nolman is a musician who's been coming to Vancouver Island for the past 20 years to perform. With a population of just 4 people, Telegraph Cove on the east side of the island is hardly a choice venue for his concerts. But a few miles out to sea, Jim has a larger audience waiting.
Looks like they're coming right towards the boat, Bob.
It's time to rig up the stage.
Take my trusty green cord, plug in the underwater speaker. Underwater speaker walks off the end of the dock. This is a hydrophone, and it's basically an underwater microphone. Here it goes.
Everything is now set for an underwater jam session. The other members of the band shadow the boat. By jamming with killer whales in the wild, Jim hopes to unravel something of their language.
So now they're on to us. You can hear the echolocating very focused on the boat. Yeah, now they're starting to vocalize, but they're not in pitch yet. An orca's signature whistle is kind of like a little guitar riff. It's a riff. It's a little hook, a musical hook. And when they establish that and sound that, I like to bring it up a half a tone if I can lock onto it, and to see if they'll come with me. Because if they come, now they're really in my ears. Okay, I'm going to play.
The underwater symphony drowns Jim out. The next day, Jim heads for Johnson Strait. It's a popular spot with whale watchers.
So this song is called The Boat Noise Blues. I don't know what else to name it. So much boat noise in this area. So the trick is to play when they're not vocalizing, and then stop before they vocalize, and not play anything when they're vocalizing. So then you get the sense of the dialogue going on. I believe that music is a language, and I believe that coming out here and doing that is running a language experiment. And it's not science, but I think that you don't need to be a scientist to do language. One of the things I see missing in a lot of the language studies, and the difference between maybe an artist and a scientist, is that I'm not trying to solve mystery. I'm there to celebrate it. And in a way, it's rather than trying to figure out if whales have language, I already know they have a language, and I'm there to enhance that and kind of bring that to a human culture, and to figure out some very tricky kinds of media to do that.
Jim's approach to language is not scientific, but Dr. Hauser agrees that even scientists don't have all the answers.
I am very open to the possibility that we've just missed the boat on interpretation. I mean, I think, at some level we're stupid as scientists. We don't have a good way into understanding what these calls mean, and we've had extremely primitive methods. So, yes, the jury's out about whether there might be other systems that have the power of language for expression, but it seems to me that after 100 years of work now, I think the reasonable conclusion is that many animals have a much richer conceptual life than they have the capacity to talk about that inner life. And that poses a really tremendous paradox. The animals are thinking rich thoughts, but don't have the vehicles to express them.
Theirs is a world that remains largely closed to us. Whatever linguistic abilities animals do possess, nobody has found an animal language as rich as ours.
How many green blocks? How many green blocks?
Where's orange? Orange. Great. Oh, there it is.
How many green blocks?
I'm not helping you.
Come on.
You're cheating.
How many green blocks? Green block. No, all right. Let's do something else for a little bit, okay?
Find orange. Orange. Good job. Very good.
Our planet is a wild animal playground. Games play a serious part in the lives of mammals. But why do they play? What's the point if games sap their energy and are often deadly? In the daily struggle for survival, it's odd that play should be such a high priority in the animal kingdom. Yet some animals, like bonobos, our closest relative in the wild, spend hours at a time monkeying around to the point of exhaustion. So scientists are trying to find out whether the benefits of play outweigh the costs. It's difficult to understand what play really is, what good it does, and how it evolved. In short, how exactly do you define play? Most scientists agree on one thing. You don't need a reason to play, especially if you're a bonobo in the rich forests of the Democratic Republic of Congo. Games here, like everywhere, are entirely voluntary. All you need is the desire to join in. But animals, like humans, also need to be relaxed. Sad or stressed animals don't play. It's often obvious when animals are playing. Play fighting, hunting, and play mating are popular games. But it's equally easy to mistake work for play. In marine parks all over the world, animal acrobats look as if they're having a ball as they practice jumps and somersaults for much of the day. But their behavior here is neither spontaneous nor voluntary. They're training hard to entertain others. Handlers put them through their paces. John Kershaw, curator of Marineland in the south of France, is careful to distinguish work from play.
You have to be very careful interpreting what you see here. You can't just say that the animals are constantly playing. These animals also need certain constraints in their lives. They have constraints in the wild, and they need to have problems to solve and to feel good about finding solutions. So what we call games for these animals are in fact serious problems. They have to work around a problem to understand what we want out of them. So the game is no longer a game. We give the animals constraints for their own satisfaction.
Without the stimulus of mental challenges, animals get bored and depressed. Although these dolphins clearly enjoy their job, real play is spontaneous. Some animals are game for anything, and scientists now believe animals play because it's fun. As with humans, age makes a difference. The young tend to play more than adults, and some species of animals play more than others. For decades, Mark Beckhoff, a biologist at the University of Colorado, has studied who the real players are in the animal kingdom.
In a given species, the young animals play more than the adults typically, and that's because the young animals aren't responsible for their own life. They get fed, they get protected, they get shelter. Typically, play occurs in the younger animals when they can be irresponsible. Younger animals can also get away with biting older animals, but once a younger animal becomes a competitor for food or for a mate, the older animals don't like to play because then the younger animal is a threat to their status.
The fun begins soon after birth. Some animals can't wait to get out there. Only a few days or even a few hours old, they're already biting, scratching, and rolling about with abandon. Up until now, scientists believed infant games were essential for learning skills like hunting, fighting, and mating. The young imitate their peers, running, chasing, and wrestling, all vital skills in themselves for survival. Today, the theory that the animal playground acts as a classroom has fallen out of favor. Scientists now think the benefits of play are far more subtle and immediate. To start with, games offer physical exercise, and they may help to cement social roles and communication skills within a group. Scientists even suspect the fun instills psychological and physical well-being. Play could also prepare young animals for taking risks and dealing with unexpected situations. Not a formal apprenticeship so much as a quick prep. So why do some animals play more than others? Dr. Gordon Burkhardt at the University of Tennessee has a theory about which animals are game. He calls it the surplus resource theory.
Well, surplus resource theory is a sort of an idea I came up with to try to explain why some animals play and the context in which animals play. So the idea is this, that play is found in animals when times are good. So we know that animals where they have a lot of nutritious food and resources are abundant in the wild or in captivity play more than animals that do not have sufficient food, or they're spending all their time finding food. If you are spending all your time doing things that you need to for survival, then you're not going to have the time resources to engage in something that seems to be, for the moment, not really serious or valuable.
Olive baboons live throughout Central Africa. They fit right into Dr. Burkhardt's theory. They feed off grass, leaves, and fruit, with the occasional small animal complementing a mostly vegetarian diet. Food is never a problem with the baboons of Kenya's Masai Mara National Reserve, so they can afford to spend a lot of time sleeping, grooming, and playing. Youngsters have plenty of energy to use up. They're fed by their mothers for the first 2 years, so they don't have to waste precious playtime foraging. Baby baboons join in the fun a few weeks after birth.
Animals that have a fair amount of parental care when they're young, which is when you find most play. If you have parents providing you with resources, protecting you from enemies, keeping you warmer in the environments that are conducive to your survival, then you, in a way, are sort of, in a sense, sort of bored. In other words, you have time, resources, you're being given the nutrition that you need for development, and so again, that's the context in which you would see play. So we know that animals with prolonged parental care are more playful than animals that have shorter parental care.
Baboons live in troops of up to 200 individuals. Babies stick close to their mothers, and with the ever-present threat of predators, babysitters are never in short supply. After 2 years' close supervision, adults let go. Parents are permissive, so youngsters are free to explore the most extreme adventure playgrounds. With ample food and parental protection, youngsters can play to their heart's content. But they're not the only reasons.
Another factor here is that animals that can do a wide variety of things with their limbs, their faces, their bodies, we see that they play a lot more than animals that are much more limited in the kinds of behaviors that they can perform. So if their normal repertoire involves lots of different activities, typically we find that these animals can rearrange and put those behaviors and those movements in different contexts and practice different things with them, and that seems to be a factor involved in play.
So young baboons take full advantage of their physical gifts to muck about. As adults, they'll need to master a wide range of terrain, crossing rivers and climbing trees in search of food wherever it's to be found. Olive baboons spend their first years testing themselves to the full against their environment. But the young also dice with death. More young animals die playing than practically any other way, even under adult supervision. In spite of being a vital part of their development, games can lead the young astray, both on land and sea. Sea lion pups in the southern Indian Ocean are born on land in relative safety, but they spend most of their lives at sea. The transition from land to sea marks a perilous watershed for the young. They've little time to become competent swimmers. Pups pick up basic water skills in the baby pool. Water sports use up less energy than sport on land, so it's no surprise that marine mammals are among the most playful creatures on the planet. After a few months, sea lions are ready to brave the open waters and play in the waves and currents. All good practice. But a maiden dip close to the shore is still risky. 80% of young sea lions die at this stage in their lives because when they play, they just don't see what's coming. It's hard to imagine why they play so much considering such heavy losses. If pups in the wild toy with death, those in captivity are sitting pretty. These youngsters are already expert swimmers, and today they've got a new toy. Even an empty plastic canister holds great interest. Mammals in the wild spend up to 10% of their lives playing. Recreation soaks up even more time in captivity because there's no need to hunt or worry about predators. That doesn't stop the sea lions of marine land showing off their natural predatory instincts.
For a young animal faced with a strange new object, it will make its approach cautiously, and once it's seen that the object isn't dangerous, it'll start to play with it. In the case of a sea lion, the games will be related to hunting. In other words, it'll try and kill the canister, bring it back, and dominate it.
Born in captivity, this pup lives to play. Yet its body language resembles the wild sea lion trying to dominate its prey. In captivity, the young seal has time and energy to try out different techniques to get a handle on something completely inedible.
The toys become games where the sea lions practice domination. He'll try to keep the canister for himself, and he'll try to keep others at a distance. So this kind of play has two functions in life.
Sea lions do the same in the wild. Other marine mammals share a passion for play, but not in the same way. Dolphins aren't as skillful as sea lions. They can't use their flippers to control objects. A sea snake is hardly worth eating, but it is worth teasing. Killer whales, like dolphins, use their mouths to play. Tugging seaweed provides light entertainment. At Marineland, killer whales are training for the big day. Performing is essential for their general well-being. Animals as intelligent as these would suffer greatly if they had nothing to do. But the trainers are careful to allow them time of their own. The question is, what toy do you give to an animal over 20 feet long? A little white canister seems tiny. Killer whales need a toy more suited to their size. This time, John Kershaw and his team don't interfere.
When we leave the animals alone to play with things, then they do what they want, and they'll use what they've learned. That's play. What they do generally with us is not play.
Left to their own devices, the whales prove far less ambitious, even dull. This would hardly entertain an audience. The fact is that in spite of their acrobatic skills, killer whales are cerebral animals. In a human world, they'd be more likely to play chess than chase. This ocean intellectual is in danger of becoming a laughingstock with this trick. But John Kershaw isn't laughing. He's in awe.
We've seen a killer whale with a barrel on her back. But what you have to understand is that although this behavior looks somewhat static, actually it was the whale that started by denting the barrel so it would sit comfortably on her back. So she changed the shape of the toy to be able to carry it on her back. Now that's intelligence.
This killer whale shows what influence intelligence bears on play. So does brain power separate the players from the spectators? Sharks don't play. No surprise there. Baby sharks are born into an adult world and must immediately fend for themselves like miniature adults. Unlike killer whales, sharks hardly rank as Einsteins of the sea. Nor for that matter, do turtles. So does their low intelligence stop them from playing? Possibly. What's more, they don't need to adapt further to survive. A real killjoy. These two species evolved into their present forms millions of years ago and are perfectly suited to their environment. Predator and prey live and die at either end of a food chain that hasn't changed for millennia. The same is true for a group of Mediterranean turtles at Marineland. They've lived here, free from predators, for 30 years. And their interest in the new toy is somewhat underwhelming.
Turtles don't play. It's an animal that's lived in its present form for millions of years. So this animal is fairly well evolved. It won't change much more, and it doesn't use much brain either. It survives on instinct and eats what it's always eaten. This animal won't adapt further. It's not very intelligent, and so this kind of animal won't play. Both intelligence and the need to adapt to a changing environment appear to favor playfulness. Most mammals work constantly to find new ways of surviving, and games seem to create solutions. Reptiles are such old hands at survival they don't need to reinvent themselves. Dr. Burkhardt also thinks reptiles are not physically cut out for play in the first place.
So one of the reasons that we do not see play as much in reptiles and other, quote, cold-blooded animals is that they do not have the metabolic muscular capacity to engage in vigorous activity for long periods of time. So something like an iguana or the monitor lizard can really move fast if they have to avoid a predator or to chase down a prey item, but they tire very easily because their metabolic system cannot process oxygen through breathing and circulation the same way that mammals can. So they are not capable of sustained vigorous activity, which is one of the hallmarks of play.
Reptiles conserve their energy for when they most need it. Why move if you don't have to? Wasting energy could prove fatal in a crisis. For years, scientists put all reptiles squarely in the non-player camp. But when Dr. Burkhardt applied his surplus resource theory, he found an interesting exception. The monitored lizard does play. if you're patient enough to watch.
So lizards that can do more things, like this monitor, it can use its paws, it can use its snout, its tongue. You're probably going to find more play-like behavior, playful behavior in this type of animal than you would in a snake, which has no limbs, can't really do much with its mouth except eat. In the lizards, in a variety of species, we find pretty good evidence for play. But again, not nearly as sustained, not nearly as universal as you find in mammals.
So some reptiles do play, although not as much as mammals. Monitor lizards, in fact, have high metabolic rates compared to other reptiles and are even credited with some intelligence. Another feather in their cap is their tendency to hunt actively rather than wait for prey to come to them. So there's value in a game even for a lazy old lizard, as long as it doesn't run into overtime. Mammals, on the other hand, never let up. Their playful behavior is easy to recognize. But there's more to their games than meets the eye. Macho play shows dominance, and when mammals throw themselves into the fray, they do so with strong predatory instincts. Their games amount to more than just physical movement. Scientists divide animal play into three distinct categories. First comes object play, and it speaks for itself. Locomotor play involves running and jumping, usually alone. And social play calls for a partner. Some animals combine all three types of play, like dogs when they race around fighting for control of a toy. So what rules govern these games? In captivity, animals play with objects made specially for a game. In the wild, anything is fair game, including other living creatures. Predators are naturals when it comes to object play. They stalk, manipulate, and explore anything that's new. When their curiosity is satisfied, they move on. Hoofed animals are locomotor players, running, bucking, and leaping about in short, unpredictable bursts. It's a commonly observed activity in animals threatened by predators. Domestic cows on a ranch in Colorado may not face many threats, but they're born with the same instincts as their cousins in the wild. Scientists think locomotor play may help animals develop specific muscle groups, and in the open African savannas, that can mean the difference between life and death. Barely out of its mother's womb, this calf must be up and running as quickly as possible. Its first tentative steps mark the beginning of a period of play that will last until it's stable and quick on all fours. Without the benefit of play, a wild calf out here stands little chance. If you need a good kickstart in life to survive in Africa, macaques on a reserve in Puerto Rico start life with a punch-up. Their social play involves chasing and wrestling in what looks like a gentle dress rehearsal for future adult conflicts. In other species too, infants brawl, but their games could never be mistaken for what their peers get up to. When young elephant seals play on the Crozet Islands in the southern Indian Ocean, they mimic the behavior of adult males. The elephant seals gather here in huge colonies to breed on land once a year. The pups mouth fight as if competing for females. But the stakes are low compared to the ferocious rivalries of adults. Powered by over 5,000 pounds of muscle, bone and blubber, they battle it out to preside over a harem of up to 50 females. In Uganda, male cob antelopes partake in similar duels. Like elephant seals, the only rule here is winner takes all the local females. The urge to win is driven by the urge to father offspring, so this is no game. Where adults lock horns over the right to pass on their genes, young antelopes mimic their behavior. But even with young animals, there's always a risk of getting hurt if a game turns ugly. So how do players know when the rules have changed? Scientists believe that some animals do communicate their intentions, like these wolves in Abyssinia. Mark Beckhoff has deciphered some of the signals.
If you just watch animals, sometimes if you're not familiar with them or if you don't know who they are, you don't know they're playing. But one way you know they're playing is they don't bite as hard as they could. They don't shove one another as hard as they could. They don't slam their hips into one another as hard as they could. And during the play, they'll do these play signals. So for example, in dogs and wolves and coyotes and foxes, they'll do that bow where they get down on their forelimbs and put their hind end in the air and wag their tail and sometimes bark. They'll do that to say, I want to play, and then they'll intersperse it into the play bout right before they bite, saying, I'm going to bite you, but this is play, or I'm sorry I just bit you, let's keep playing.
Chimpanzees have their own protocol which keeps play clean. The game is physical enough, but notice how the chimp is open-mouthed. It's a relaxed expression which may well be the origins of the human smile. This play face shows that however tough the going gets, intentions are honorable. Chimps also vocalize their playfulness with panting noises, equivalent to human laughter. Humans laugh most when they talk. Chimpanzees laugh during physical contact and when they tickle each other. But chimps don't just use their faces to reassure their partners. A handshake does just as well. Great apes extend their arms and use exaggerated gaits, as if to say, it's just a game. During a brawl, they lightly gnaw hands and feet. Chimpanzees are highly social animals and their games reflect this. But social play is not restricted to animals that live in large groups. High above the Arctic Circle, polar bears lead solitary lives. The young stay under the protective wing of their mothers, so they have plenty of time and energy to fool about. The choice of toys may be limited in this playground, but that doesn't discourage the bears. Like many predators, the polar games seem to mimic behavior they will use later on in life. But age doesn't spoil a bear's appetite for fun. Polar bears wander the ice packs alone in search of food. Most of the time they stay out of each other's way, but when they cross, they often make the most of the company. Play is almost entirely social. Adult bears play fight, but surprisingly not for domination. Gordon Burkhardt points to a paradox in the behavior of polar bears.
Bears are really interesting because people have argued in the past that social play should be related to their complex social organization. The problem is that bears, except for the mother or offspring bond, are not very social animals. They do not have a complex social organization. Yet they are some of the most playful animals on the planet. So that's sort of a paradox. You cannot use them. Well, they're practicing all these moves, all this in play fighting and play chasing and object manipulation. They're practicing just for adult social behavior because it doesn't seem to fit.
If polar games have nothing to do with the bear's social life, why do they play? They certainly get a good physical workout and probably enjoy the mental stimulation. Could they also be sizing each other up for future, less friendly encounters? One fact is certain. Bears live at the top of their food chain so they can play without worrying about predators. In fact, their own worst enemy is another polar bear. Such powerful animals could inflict terrible injuries on each other, so they're careful to keep the temperature of the game down. Dominant bears deliberately hold back, something scientists call self-handicapping. Mouthing and jaw wrestling are popular games. Those that play too rough are always the last to be chosen as play partners. Although in some play situations, one partner may be more keen to participate than the other. At the opposite end of the earth, another awesome predator also knows how to play with kid gloves. The leopard seal hunts fish and penguins in Antarctica and has even been known to kill humans. Up to 12 feet long and armed with a mean set of jaws, these animals make short shrift of their prey. No prizes for guessing what happens next. The penguin has no chance of escape. Or does it? The seal plays cat and mouse around the ice floes, careful not to damage its edible toy. To prolong a one-sided game, the seal takes self-handicapping to new heights. From the comfort of their home, cats also excel at predatory play. Their urge to hunt is so strong that any object provokes an attack. Domestic cats keep their predatory instincts throughout their lives, and grown cats are just as likely to play with a toy mouse as a live one. Such simple observations spike the old theory that play helps animals hone specific skills for adult life. Scientists like Dr. Burkhardt discount any link.
People have tried to look at the function of play and do experiments. For instance, do kittens that play with balls of yarn or fake mice, are they better hunters when they actually have to hunt mice on their own? That obvious idea that seems so straightforward doesn't work. And there's a wide range of evidence showing that these very plausible sounding arguments for why animals play do not really hold water.
The experts are convinced that animal play does serve a purpose, even though it may not be formal training for the future. So why do animals in captivity, as well as in the wild, play with their prey?
This idea that animals may capture a prey item and then release it and capture it again and so on, that's a game. It's something that we can very much empathize with this sort of doing. You want to keep the game going. They may be enjoying the chase, enjoying the game, and they're not really hungry. They're not really doing it because they want to kill or that animal at that moment. But this is a way of keeping the engagement going.
The seal is content to call it a day. Only scientists are left to wonder why. The adult seal is already a skilled hunter. He hardly needs practice. So the game would seem to be a waste of time and energy, not something Mother Nature would recommend. But Mark Beckhoff does.
Up until about 20 years ago, people thought play was a waste of time, energy, but it's not. It's very important because when animals play, they socialize with one another, they get physical exercise like aerobic and anaerobic exercise, and they also train their cognitive skills, they train their locomotor skills. So play's not a waste of time at all. Play's actually very important for development. And what we see in animals who don't get the opportunity to play is that they don't develop socially, cognitively, or physically.
Although the study of animal play has become widely respected, the subject continues to frustrate scientists. The function of play defies easy definition, although it does seem to be good for animals, even vital to their long-term well-being. Play probably encourages mental development and helps animals react to unexpected events. But aren't scientists overlooking a much simpler explanation for animal play?
I think one real cause of play, and it might be a function of play, is to have fun. I mean, there's no doubt in my mind that dogs and cats and some birds and wolves and chimpanzees love to play, and I think it's the positive reinforcement they get. They love to play, they enjoy it, so they play more. And evolutionarily, there's no reason to think that something that's fun won't be kept in the behavioral repertoire.
Whatever the reasons for play, it does seem to do animals more good than harm. It shows that people don't hold a monopoly on leisure, and perhaps animals, like us, just do it.